Hello everyone, in this video we want to tackle the thinking behind calculating the net electric field, and as the previous quote suggested, everything is simply going to be a combination of a few core principles. So there are not a million things you have to memorize. Your core principles and calculating the net electric field will simply be a combination of those. The first core principle: if you have a field generated by a positive charge, that field is going to radiate outwards. The second core principle is that if you have a field that is generated by a negative charge, that field is going to point in the direction that faces towards or pulls towards the negative charge. And the third core principle is that the field that is generated by the charge, right, is proportional to the magnitude of the charge, the size of the charge, and the distance between Q, which is causing the field, and the reference point in the question. Okay, so remember, this charge is causing this field, causes this field, and you can have different charges because you can have multiple of these sums, right, equations where you add them up to calculate the overall or the net electric field. So you can have a subscript A, or you can have a subscript P, or Q1 and Q2, etc. So let's tackle this meaning here, the reference point, because a lot of questions will ask you calculate the net electric field that is experienced at a certain point. Like all vector equations or equations and problems dealing with vectors, you have to establish a positive direction. So for the sake of this video, for all our problems in this video, let's have right as positive. Okay, so that's going to be our reference frame. And then let's look at how we will calculate if we have this situation. So if we have a positive charge and a negative charge, and you want to calculate the net electric field at this point, let's give some labels. So I've labeled this QA and QB, but they can be Q1 and 2, Q apple and Q orange, as long as you know that there is a distinction. So if we want to calculate the net electric field, we have to set up that equation. So the net electric field will be the sum of the fields generated by these two charges. Now let's add the equation or the formula for the net electric field. And now we have to decide what sign we're going to put in between them. Are we going to add these values or are we going to subtract these values? Remember, even though this is generated by a negative charge, you don't put the negative sign in this equation. Where you determine the direction is at this point in your problem solving, because you want to see what is this what is the net field going to be experienced at this point. So now let's determine the direction of the electric field due to each charge at this point. So we know from one of our core principles, right, that the QA will generate an electric field that pushes away. So we can represent that by drawing a vector and saying that this is now the direction that will be experienced at point M of the field due to QA. So I'm labeling it EA. Similarly, I can label the field that is going to be experienced at this point due to QB. I can also say that because our second core principle, that negative charges generate fields that point towards it, that this field will also point towards the right. So this is the charge experienced, or this is the field experienced at M because of QB. So now we have two directions. That's actually one direction, and they are pointing towards the right, which is our positive established direction. And because of that, you will write a plus sign here. So when you substitute your values, you will simply add the fields together and you will get an answer in newtons per coulomb to the right. So in scenario 2, I have the same charge setup, except now my point is on the outside of this field. So now let's see the direction of the electric field that is contributed towards by each charge. So if I'm at point B, the field I will be experiencing as a result of charge A over here will be towards the right, okay, because of our positive charges generate fields that radiate outwards. So the direction of the field contributed to by charge A will be towards the right. And so if I'm standing at P and I want to find out what is the direction of the field that is contributed towards by charge B, I know that because negative charges produce electric fields that point towards it, that the direction of the field will be that way, E, B. And so now I have two different directions. And now when I set up my equation, I set up my net calculation, I'm going to leave this as a positive number, but I'm going to subtract this field from the field generated by A. In other words, I can also add a negative. Okay, that's another way of subtracting something. So I'm subtracting it, or this is a negative value because my established direction is positive. And if I am at point P, then I will be experiencing a tug or a force from both sides, right? The field that I will experiencing because of charge B will be towards the left. That's why I'm subtracting it according to my reference frame. And then the field that I'm experiencing that's produced by charge A will be towards the right. Scenario 3 is if I have a point in between two positive charges and I'm labeling them QA and QB. It's my fields. Let's establish the direction of my fields due to each charge. Okay, they are in different directions because our positive charges will radiate their fields outwards away from them. So I will have a subtraction situation here. If my point of reference is on the outside of two positive charges, both the field generated by EA and the field generated by QB, will be towards the right hand side because positive charges radiate their fields away from them. This would be the setup if I had two negative charges and I had point P in the middle. I would subtract them from the fields from each other because both of these charges generate fields where the direction of the field is towards them. And in this scenario, if my point of reference and the point in question is outside, then I would these fields would be compounded. The strength would be, much bigger than if I just had this situation. So at this point, I would feel a much bigger electric field towards the left hand side. So you would add them, or you could change the direction for the left to be positive and then you can add them. And so just to summarize, these are the three main things you need to keep in mind. Number one, if you have a field generated by a positive charge, the direction of the field will be outwards. If you have a field generated by a negative charge, the direction of that field will be towards the negative charge. And I put these asterisks here as subscripts in the equation, just to remind you that this equation is specific to whatever charge you're talking about, and that the net field, you will add them or subtract them based on where your point is. Okay, so remember this field, and to calculate the net force, you're not going to put the direction in or the sign in this equation. You're going to put it outside once you've established a positive direction or a reference frame, and then you can decide, are you going to subtract the fields or are you going to add them.